So now that you know how to evaluate a piecewise function and graph one, and you practiced, we are going to, you wrote an equation based on a graph. Now we're going to graph them, and we're going to talk about how you can write an absolute value function as a piecewise function, because that's essentially what it is. So if you don't know what I'm talking about, you'll see it in the video. Let's graph the following function on the axes provided. So we're just going to start with A, and in each piece, I'm going to graph each piece. So we're going to start with this one. Okay, now anytime they give you this number, what we're going to do, the very first step is, the easiest way to graph these is to take this number and plug it in for x. So we're going to take that number and we're going to plug it in right there. So it's going to be -5 minus 6. Well, that's 5 minus 6, which is -1. So we're going to start at the point -5, -1, because -5 is what we plugged in, and -1 is what we got. So we're going to come over here to -5, -1, and that is a closed point. I know it's closed because there's an or equal symbol right there. Now I'm going to use the slope. So I'm going to erase this. I'm just using the slope. Remember, the slope is the number that's right in front of x. Our slope is -1, and because it's -1, it's over 1. That means the slope is going to go down 1, right 1, or up 1, left 1. Because -1 over 1 is the same thing as 1 over -1. And remember, this is the rise, this is the run. Rise, run. Now, because my x is less than -5, because that's my domain, I need to be able to go to the left. So I can't go up 1. I can't go down 1, right 1. This is not the one I'm going to use. I'm going to use this one because I need to go to the left. So it's going to go up 1 over 1, up 1 over 1, up 1 over 1. We connect the dots. And there you go. That's that part of the graph. I'm going to do the same thing for the other piece, but I'm going to use green, right? And that's this one. Okay, so I have the point 2, comma, and then -2 is all I have. There's nothing else to plug it into. So I'm going to start at 2, -2. And that's not an or equal to, so it's going to be an open circle. Now remember, just like when we were writing our equations, when you have just a number, it is a perfectly horizontal line, which makes it much, much easier to graph. You don't have to worry about a slope or anything like that. Let's do another one. Now we're going to start here at the top. So we're going to start with this top piece, and it is or equal to. We're going to plug in -3. So -3 plus 4, because we're taking that and plugging it in right there. And that is 1. So we're going to start at the point -3, comma 1. So let's go to -3, 1. That's going to be a closed point, and it's going to the left. My slope is just 1, so it's 1 over 1. So that means up 1, right 1, or down 1, left 1. If they're both negative, then they're both negative. So that's doing something like that. You always start where you were, and then because it's arrowed to the left, we're going to the left. For between -3 and 1, we're at 6. So here's my advice. If you have a starting and an ending number, you plug them both in. So I have -3. Now because this is just 6, my output is 6. I have 1. So I'm going to have 1, comma 6. So my output's always 6. So I'm going to go to -3, 6. I'm going to draw an open circle because that's not or equal to. So you have -3, 6, open circle. That's my starting point. And I'm going until I get to 1, 6. So 1, 6, open circle again because it's not or equal to, and you just draw a line in between. When you have a starting and an ending point, you plot your endpoints and you draw a line in between them. And that's it. That's all you had to do for that piece. We've got one more piece here. It's this one at the bottom. So we're plugging in 1, so it's -1 plus 9, because we're taking 1 and plugging it in for x right there. That is going to be a closed point, so we're going to have, let's see, 9 minus 1 is 8. So we have 1, comma 8, and it is closed. So let's go to the point 1, 8 and draw a closed point. Now we're going to use the slope. The slope here is -1, because there's just that imaginary 1 right there. -1 over 1. And this time, because x is greater than 1, I'm going to go to the right of this point. So I'm going to go down 1, right 1. Down 1, right 1. It's going to do exactly what you think it should do. And it's going to keep going forever and ever because it never stops. That's how we graph a piecewise function. If you need more explanation, remember when you're doing your practice, there are videos, so make sure you watch those. Now let's get into what an absolute value function is. In previous math classes, you learned that when you take the absolute value of a number, it makes it positive. You can also think of this as the distance from 0. Okay, but either way, you're taking numbers and making them positive. Now what happens here is if you have something like this equation here, x plus 2, so a basic absolute value function is a v. And it's normally centered at 0, 0. So it'll look something like that. This right here, that x plus 2, that moves it to the left 2. So that's going to shift it over, and that's why this graph looks the way that it does. It's the same graph for 0, 0, and it's moved to the left. And it's just 2 lines. It's one positive line and one negative line. So there's 2 ways that you can think about an absolute value function. You can think of it as a piecewise function, where it has a positive side and a negative side, or you can just take this v and shift it. If you can remember that inside, you're going to do the opposite sign of what's there. The opposite sign of what's there. So if it's x plus 2, it's not to the right 2, it's to the left 2. And then if it's x minus 2, it would be to the right 2. So that means right 2. Okay, so these are shifts in our graph. We're going to go over doing both of these things. So in order to write an absolute value as a piecewise function, the first thing we need to do is see where it equals 0. So let's take 2x minus 8 just over here to the side and set it equal to 0. So 2x equals 8, which means x equals 4. So we're going to have 2 pieces, the positive version and the negative version, and one of them is going to be where x is greater than or equal to 4, and where one of them is less than 4. The positive version is going to be greater than 4 because there's nothing weird going on in this graph, so it's just the equation the way we see it. The negative version gets a negative. So we're just going to take a negative and throw it in front of our equation just like they did up here. Okay. The only difference between what they did in the example here and mine is that I put the negative second and they put it first. Okay, that's it. Now B is slightly different. B is a little different because it's 2 minus x, which actually means the same thing as negative x plus 2. Right, so that's going to be a slightly different type of problem. Either way, we're still going to have to take 2 minus x and set it equal to 0. So if you add x to both sides, you get x equal to 2. So it's going to switch when x is, so we're going to have greater than 2 and less than 2. It doesn't matter where you put the or equal to. They're gonna hit each other anyway, so it doesn't matter too much. Now the difference here is that normally I'd say the positive version just looks the same. In this case, the given version is actually the negative version. So it's negative x plus 2 because it starts with a negative slope. That's all. Okay, that means that's the left side of your graph. Then the positive version is going to be the opposite. So it's negative x plus 2. So you just have to pay attention to the sign of your slope. And then everything else will fall into place. The last thing we're going to do here in this video is graph these absolute value functions. One way you can do it is by taking a bunch of x values and plugging them in. Another way you can do it is by looking at those transformations. So again, we normally have just a v centered at 0, 0. But this means it's moving to the right 5. So instead of it being at 0, 0, it's going to be at 1, 2, 3, 4, 5. It's going to shift it over here. And then that's going to move it up 3. So my graph is not going to be at 0, 0. It's going to be at 5, 3. So it's kind of like we have we have a new vertex. Otherwise, it is exactly a V like we're going to be used to seeing, right? We're not used to it yet, but we will be. Let me do another one in case you didn't get that one. That plus 2, that means we're moving to the left 2. And this minus 4 means we're moving down 4. So if it's outside of those absolute value bars, this number right here and this number right here, you do the sign that's there. When it's inside, you do the opposite. So my V is moving to the left 2 and down 4. So my V is going to be over here instead. And then we've got those straight lines. We're going to pretend that those are straight.